Hi, good evening. Today we are going to show you an example how we can deploy a smart contract inside another smart contract. Okay, so let's look at what we have over here. We have a few file over here. I'm not going to go through each one. So basically, this is abstract contract or initializable. Basically, we want to use this func contract, which is abstract to initialize another contract. And this is its interface. Just declare every contract need to have this init function. So, and this is simply the mean to allow to set the mean for a particular contract. I'm not going to go through that either. This is the file we're going to look at today. And then here's the contract only me, which we are going to deploy. One interesting about this aspect is we want to explore is we can actually know the address that this contract is going to be deployed before we even deploy it. So that's crazy, right? Because actually one of the experiments people did, which I'm not going to do today, is you're able to send some Ethereum to that particular address first, which we already know in advance, and then using this only me to withdraw it. Is that crazy? So you don't need to know the password or secret key for the address. Everybody know that address. Only whoever deployed this contract can actually put this contract there, and then actually be able to specify who is the beneficiary, and then only the beneficiary can withdraw that amount of money from there. So, I mean, I will encourage you to try this afterwards. My video, you can send Ethereum 7 to that address and then using this to withdraw it. Okay. So without further ado, let's explain how it works. First of all, we're going to come back to this. Okay. So we're going to try two ways. The first way is pretty easy. So basically, this is init. We click it and it's going to set a bunch of variable over here. Don't worry about it. Test init, just trying to see, just trying to call this. So we are going to use test init to call this. And then we can use this to check if it's init is done or not. And we can only init once. So if we try it again, it's not going to work. Okay, because we can try. So test init, we can try that again. And then, so this is the first way. Simply use a new, and then the argument, and then this is going to be deployed. Let's try that one first. So before we do, let's compare these. So we compare. Okay, we're successful. And then we have not deployed. So let's deploy these. Okay. Okay, successfully deployed. And then over here, we can, as we talk about, we could we could try the test init. Okay, actually right now let's just say let's just call it, is this done or not? It's false. So if we test it, call it, and then it's successful, you call it again, it's going to return true. And then if we click again, it's not going to work because it's working. What's wrong? Test init. Okay. Test init. Okay. Here we didn't check the we didn't check the return. So regardless of this, so test init is going to be transaction is going to be successful. Okay. Okay. We click test deploy one. So we click test deploy one over here. So it's going to immediately deploy the address. So as you can see, if we click this, then we should be able to see it's deployed successfully. And then this is the immediate event. So this is the successful address. Start with a 9.3. As a matter of fact, this address is decided by the, it's a function of the contract address of this and the nonce of this contract, which is going to increase by 1 every time we do a test the deploy. So we could continue to click it again, actually, and then it's going to deploy another one. And so it's going to be another instance over here. And each time the address is different. You see that? So at least we have two instances of the only me already deployed, and they are all successful. They are all different address. And by the way, if you click the if we click test in the game, it's going to fail. As you can see, it's going to revert. The reason it's going to revert is because init is going to revert, because over here we are checking if it's initialized or not, and otherwise, if it's already initialized, we're going to revert over here. Okay, so that means init can only be called once, so we already call it. Now let's do something crazy. Okay, over here we can actually get the address that we're going to deploy. So for example, suppose remember these only me have an argument. Okay, so before you deploy, you need to provide the argument with the beneficiary. So let's say I'm going to put the beneficiary as the last person, DB. And this one I'm going to copy this. Okay, so it's DD. So I'm still going to use the first account to execute. So over here, if I trying to predict the address we're going to do, and first of all, there at least get address take two arguments. One is the sort. I'm going to use this sort, and then the argument for the constructor. Okay, beneficiary. So if I click this, okay, this is the address. Is that crazy? So this is the address we are going to deploy. We actually know before we deploy this, and the way we calculate it is actually according to a created to rule. So if you go back over here, create a to rule, we get the address is this. Okay. So first of all, you use a get bytecode of owner to get a bytecode. So this is the bytecode of the contract only me. So we can actually let me see. Where so this is how we implement get by me. We first of all we get a creation code, and after we get a creation code, we encode it using encode packed as well as encode. So the reason we need this is because the creation code also need the owner information in order to deploy, right? So we need to know who is the owner. There are some contract which don't have the constructor. Then in that case, you don't need this part. We simply use the bytecode and it's sufficient. We don't need to have another encode. Just the first bytecode is sufficient. Just create an encode. We need an argument for the constructor. So this is the bytecode. Once we have bytecode, this is the function to predict the address. Basically, it's using prefix 0xSF. This is to distinguish the address from this is used to distinguish from the create one. Okay, create one is something else. So FF and then the address, which is the address of this contract, and then the sort we provide. In our case, we always provide 129, and then keycat hash or bytecode, and then we use the encoder packet again on the side, and then we use a keycat to calculate another hash. So it's a one hash and a few other arguments in code pack, another hash. Okay, so that give us the hash, and of course the hash is going to be the 32, but for the address we don't need to all the 32. We only need 20 bytes. So we retrieve the first 20 bytes, the last 20 bytes that give us the address for the contract we're going to deploy, and that can be verified here. So this is the real deployment code. We get a bytecode calling the same thing. Get a bytecode over here, And then we use the assembly language, you create two over here. The first one is how much gas we are going to send to this new contract. And these two are actually the location of the bytecode that we're going to put in over here. So we actually add 32 bytes over here. This is the starting point that we're going to copy this bytecode. Okay, we are going to copy over here. And then here's the sort. So it's actually this function going to return address. So this address exactly is the address of the prediction. This is real deployment, but it's going to deploy on the same address. Let's look at it. So 0x51. So let's see if I say deploy 1, 2, 3, 4, 5, 6, 7, 8, 9. Of course, I have to use the same owner and the same owner, and owner is the argument of the constructor, and this is the sort. Then these two have to be the same in order to deploy in the same address. Okay, now it's successful. So if you can over here, you look at this, it's crazy. So this is 0x51, and last two digits 0x51F8, which is exactly the prediction. You see that? And of course, if you want to deploy again, it's going to fail because this address is already there, unless we have a self destroy function, which I didn't, to destroy myself. Okay, that's something we are going to explore next time. So thank you so much. Have a nice day.